And you said that you were going to record this one.
Yeah, I pushed record. Thank you.
I assume I got the right one.
Click share on the bottom.
Oh. Okay. I'm going to minimize this. Okay. So I'm going to go back to the beginning here just real quick. We didn't get very far. Okay. So let me reiterate this. Procedures are a well thought out sequence. They help prevent the occurrence of hazardous situations, and they should warn you when you could have potential hardware failure, which would be cautions, and injury or death, which would be a warning. It's written in a well-defined sequence, and it's given in step-by-step instructions. So before we had checklists. Well, checklists, you can do it almost in any order. But a procedure becomes a specialized version of a checklist that you have a specific sequence that you have to perform the operations in. Now, procedures contain the following. You should always have a summary of what the procedure is going to do, so if somebody looks at it, they know what they're getting themselves into right off the bat. There should be an entry conditions checklist. That means what are all the things that have to be done before it. So if I'm going to go and put propellant in the propellant tank, you should have already done a leak check, and you should have done a valve check. Once you have propellants in the tank, that's just not practical to start opening and closing valves. You'll dump propellant on the ground. It should have a hazard checklist. So it should say exactly what hazards are the potential hazards that that activity would have. And that's that hazard checklist that we have in the guidelines that we've given everybody. You go through and you can look to see what hazards are associated with what actions you're doing. So there's high pressure, or whether it's flammable liquids, there could be fire, and you should have no smoking or open flames or that kind of thing. Also, there should be a PPE list. All the personal protective equipment that you need for that operation should be spelled out in the procedure up front. Also, you should have a required skills and training checklist. So if you're doing propellant loading, you should have a propellant training for that. You should have dry run those the procedures for loading the propellant, or inserting the igniter, or putting the parachute together. You should have a checklist that has all the required tools and equipment. A lot of times with propellant loading, you need the 12-foot long Teflon hose with the quick disconnects on the end. You need the tank that is the propellant tank, transfer tank. You need the regulator. So you need to list all that stuff. Then you should have a diagram of the equipment set up. So usually you have valves and QDs all over the rocket. So where do I need to hook to? Which one is the fuel connect? Which one's the oxidizer connect? So I don't hook it to the wrong place. And it also tells you where the valves and things are. So a lot of rockets will have valves up in the inner tank section. Where are they and what are they? How do you find them? Then you should have a nominal procedure. So this is the procedure that takes you from the very beginning of setting up the equipment to put the propellant in the transfer tank, to transfer it into the rocket, and then when you're done, what you do is you break down the equipment. The contingency procedure is the opposite. It is for helping you drain the propellants out. And we've had so many rockets where you get it on the pad, somebody filled the tank from the top, like people like to do, and then you can't get the propellant out of it without taking the rocket off. People have to handle the rocket, turn it upside down to pour the propellants out. That is not a good thing to do. And then the last on this is the emergency procedures. So if there's a fire or an injury in the process of the procedure, who do you contact, who's responsible, that kind of stuff. So, nominal procedures. They move the rocket and the ground support equipment through the various stages of the launch, from unpacking it, to setting it up, to putting it on the launch rail and getting everything ready, to recovering the rocket. The nominal procedures moves the rocket from a benign, safe state to a more hazardous state. Here are some examples of the procedures that you should have, that you should train with. So, assembly of the rocket, assembly of the ground support equipment, folding the recovery parachute, installation recovery charges, placing the rocket on the launch rail. In some cases, this is a big deal. Installing the igniter, loading the fuel, the oxidizer, the pressurant, arming the recovery system, performing the countdown, and checking the safe state of the rocket for recovery. You should have a procedure at least for these. Because everybody's rocket, everybody's doing bipropellant rockets. You should have a recovery system, a pressure system. So contingency procedures moves the hazardous state back to a benign, safe state. It's a complementary process to the normal procedures to reverse their outcomes. And then usually you use contingency procedures for things like an equipment failure, you have an abort on the pad, a hang fire, or adverse weather conditions, or in even some cases, air traffic. Let's say the range decides that you can't fly because we got airplanes flying overhead. Okay, here's a list of contingency procedures. So how do you disassemble the rocket? How do you disassemble the ground support equipment? Safing the recovery system, removing the parachute, all this stuff. How to back out of the ignition system, removing the igniter, unloading your propellants, depressurizing, aborting the countdown. Okay, emergency procedures. What to do in case of an accident or injury. Who am I going to contact? You probably need somebody to come and rescue the person. So like the medical evacuation. If you got a fire, call the fire department. If you have an injury, you're probably going to need to call the sheriff's department too, because they're going to want to show up. You're probably going to get a few other federal agencies involved, especially if you are using pyrotechnic devices like igniters and things. You may end up with the ATF showing up. And then you need to have a list of who's responsible for what actions, who should contact these departments, and then where do you go for an injury. When you're injured out at Farsight, it's not really obvious where you need to go. And it ends up that my buddy Dave here had that problem just a couple weeks ago, and he found out that he needed to go to Ridgecrest to the emergency room. Well, that wouldn't have been my first choice. I would have thought maybe Mojave or someplace else, but that's why when you're doing this stuff, you need to investigate this stuff and make sure it's in your procedures. And then tell everybody about it. Okay, firing commit criteria. These are the preconditions for starting your static firing. So what it should contain is the state and condition of the rocket or static test stand. So what things needed to be assembled to get you ready for that point. Position of where the spectators are, because you want everybody to be safe and so no one gets injured. Also, you want to position your ground support equipment. What happens if you have to do a recycle? Let's say the igniter fails and now you're going to have to recycle the liquid oxygen because it's boiled off and you need a new igniter. You need to position your ground crews in a place that makes it easy for them to access the rocket, but they're still safe. And then one other thing would be clearance of roads and any entry areas into the test site. You don't want somebody coming in while you're in the middle of a test. And we have that happen all the time, and we have to stop and wait. And a lot of times it'll force us to recycle the test. Launch commit criteria. On this one here, there's actually a lot more information that you need, because now you're also looking at the condition of the weather. You have a place where the rocket can land on the spectators. Again, you need to know where your ground support equipment is. You need to have clearance on roads and on the no airplanes overhead. And actually, I should have had communication on the static firing too. You want to make sure that all your ground crew and the guys in the blockhouse are all talking to each other. And also, one other thing I'd like to stress on communications, it needs to be two-way communications. There's been too many times when we've been on the radio where you're talking and you're doing the countdown and somebody sees an airplane and they can't talk to the guy doing the countdown. So it needs to be two-way. Okay, the countdown. Now, all those other ones were what I would call basic kind of procedures where you follow them step by step. There's not too much of a hurry to get it done. But when you get to the countdown, now this is time sensitive. Usually that's why people do a 10 count, but actually what you're only hearing is the last 10 seconds of the countdown. When you see NASA do their launches, their countdowns last like 2 days. But in a lot of cases, your countdown will be like 60 minutes or so. So all that is getting the rocket ready to launch. You've loaded the propellants. You've loaded liquid oxygen. Now you're in a hurry because the liquid oxygen is boiling off. So the countdown is time sensitive. It deals with let's say you should be able to remotely control the arming of the recovery system, pressurize the propellant tanks, pressurize the pressure tanks and then do the propellant tanks, start cameras, release the pressure umbilicals, turn on the igniter, and then open the main valves.
Would you say countdown begins in theory when the rocket is officially finalized and could fire, and then everything else is getting ready and pulling?
Yes.
But that's when the countdown would officially
Yes.
begin.
So the launch commit criteria would actually be kind of like a checklist that says that you've done all the preparation stuff to get it to the point where you're on the rail. Now we're talking about you're going to launch it. And then the next one is that you need to have an abort procedure. And again, this one is also time sensitive because you need to reverse back out of whatever you've done in the countdown. So if you have a component failure, or let's say some kind of engine failure, or maybe you suffered a burn through or a hard start that blows your engine off, you want to be able to close the main valves and work your way backwards, relieve the pressure off the rocket. Now make it so that you can approach the rocket. So that's what I say here. Get you closer to a benign condition where the ground crew can approach the rocket or test stand. Now, my coworker brought up a good point about when are you allowed to modify your procedures? Well, the big thing is on procedures is you should be doing dry runs of these procedures before you ever get to the launch site or the test site. So you should work through these first as a team, as a round table. So you all discuss what you have to do on each one of the pieces. Then you should work out the bugs using the dry run. And that's where you can do red lines and things. And then also you should add your caution and warnings before each one of the hazardous steps. And that's why I'm saying the procedure is actually a procedure. It's like you're talking to your brother and your brother tells you, okay, I'm going to hit you. And then he hits you. Well, you want to know that the hazard is going to pop up before it happens. So now you're prepared. There's nothing worse than you're doing a procedure and all of a sudden you're surprised. You're more inclined to get injured with the surprise than you are with actual incident.
Can you clarify what red lines are?
Red lines are when usually what happens is you'll work up your procedures, let's say in Word, and then you'll print them out. So now you have a printed procedure. If there's any corrections that are made, that's considered a red line. Yeah, and that's true. Use a red pen when you do it so it's obvious that it's happened. If you have something scribbled in pencil and it's hard to see, then somebody will miss it. And red lines are acceptable. But when you're out in the field, you need to have the final procedure in your hand. And if you're going to change something, you can do it, but it needs to be the whole team that agrees that you're going to change it. And it shouldn't be during a time when it's a time critical function. Because that's the one way to get hurt, is to have somebody make a change and they bypass a safety step and now you're injured. Okay, that was the end of it. One thing that I wanted to make a point on too is that your procedures should be modularized and you should be using them over and over again. When you do your training, each particular function should be trained. You should have multiple people that know it, so there's cross-training. And what else? The modular part of it is really important too, because now you can use the same pieces that you use for your static firing on your launch. I know that you're not going to have everything from the static fire on the launch, but you'll have the good pieces of it. So make a modular, you can reuse them. And it makes it easy for the training. If you have one giant procedure that takes, hours to do, then it doesn't lend itself well to training. And see, what we want you to do is to practice this stuff before you get there. There should be no surprises. And if you're well rehearsed, then you have good safety. So any questions? Okay, well, I think this is the, go ahead.
What procedure count as like a contingency, or is it its own thing?
A what procedure?
The abort procedure.
It's basically a contingency procedure for a nominal. The nominal is the countdown and the abort is the contingency.
Someone calls in, says the plane overhead, and you're in the middle of the countdown. That's an abort.
You can abort or you can hold. It all depends on what you can do. Like nitrous hybrids, you can sit there for hours if you need to. Liquid oxygen's a little bit troublesome, but you can do it or you can recycle. But if you recycle, then you need to go through the procedure of depressurizing, and then you bring the guys up, and then you go through the fueling procedures again.
How long would you be able to hold for on, say, an oxygen?
We've been known to hold for like 15 minutes, but the problem with that is that you always have LOX boiling. So by the time you're ready to fly, you're probably going to end up with a lot less performance than you expect. Because once you're running oxygen gas through the injector, your performance of your engine drops to like 1/16 of what it should be, or maybe even less.
So when you said that doesn't, water doesn't happen, how do we actually, is it just visually that you see that doesn't happen, or is it like something that you're monitor for?
Okay, so what we do out at FAR is we have an agreement with the Air Force Base that's nearby. We actually have restricted airspace above us. So we have to tell them 7 business days in advance that we're going to fly. They put that into they have what's called the 2508, I forget what the rest of the name of it is. It's some kind of organizing organization that talks to all the bases that use that airspace. And they actually post it for their pilots saying that we're launching rockets in that area. 48 hours before we fly, we post NOTAMs that go into the national system so that pilots flying through that area can look up and see there's NOTAMs. But the area that we're in is uncontrolled airspace below 18,000 feet, so we actually get a lot of planes that fly through there where they never check NOTAMs. So then what we do is we usually have spotters, and as part of the countdown, we actually do a road and air check to make sure that we don't see or hear any airplanes. And then we usually go fairly quickly after that to get the launch off. We have had incidences, which I would have called a near miss, where we've launched and then a plane has flown over right afterwards. That is not something you want to do. Oh. Oh, the procedure? Do I know how to find it?
Everything else, yeah. No, yeah, we'll discuss it.
Do you know where it is?
Queued it up a little more easily.
Oh, is that? Oh, the XL is open. I didn't see it. Okay, this is what you see up on the screen. Let's see, am I sharing this? Your screen is paused.
Go to stop sharing. And then share again.
Let's see, I'm not sure. Okay, so Purdue supplied us with some procedures. It looks like well, we're at 103 right here. Where's the?
Yes, we had to cut so there is, sorry, Mark. There were 200 more after when we cut off. We had to cut some off due to some facility stuff.
Okay, well, so anyway, they've done a good job of writing their procedures. I'm actually requesting a little bit more information, but they've defined, like in the beginning of it, they put names in and who's the test conductor, and I'm not sure who all these guys, the SAF, I assume a safety officer, and then they go and they do individual lines for each step, saying who it is and what sequence it is in. So these are pretty good. And I think we're going to make these available for them to see.
If Chris says it's okay.
Yeah, Chris, if you say it's okay.
We're gonna find our facility template. We should have that available this morning. We're gonna use this for now. But I'm 99% sure we have a facility template that we use everything else off of. So we'll send that out as soon as possible.
Yeah, I've seen variations of this where it's been color coded, and it can go into a lot more detail on the organization of commands. But yeah.
And actually, the Friends of Amateur Rocketry have documents on our website where you can go and look at some of the procedures that we have. And actually, I'm planning to kind of update them. And we may have a sample, I'll do a sample propellant loading procedure that you can see with all the same sections in it things. So you can see kind of what we're thinking of. Any other questions?
Going back to the situation where we had the near miss with the aircraft, should we include that in our contingency or emergency procedures, or is it since it's something kind of outside our control? What should we do?
There should be a certain procedure that if you actually hit a rocket or an airplane hits your rocket, that you call in to say what happened.
So should we like the incident report that's just supplied by Base 11, or should we contact emergency?
It's going to be something beyond Base 11
Yeah.
by a bunch. They'll probably have NTSB here because when the Spaceship 2 had actually broken up over our site, they were all over the place out there. NTSB is the investigation arm of the FAA, so they'll probably be there for that.
But so what we can do under our control is put our contingency or emergency procedure, right?
Right.
And just in case like there's a near miss, so like nothing at that level where we actually hit something that occurs.
Right.
You could even put in your SOP, if that occurs, then
Who-
this is who you need to contact in that situation.
Right. But the problem is with the FAA waivers for doing amateur launching is basically we are to watch out for them. The NOTAM is just a nice to have for the airplanes, but we are to avoid launching airplanes. So it's the onus is on us. It's not on the airplanes because not everybody needs to go and look at NOTAMs.
I was just gonna mention, our faculty advisor in the past has put out like ads in the paper and ads in the radio saying that we're gonna do a launch. Just because we have a very active airport and we don't have like a designated launch area, we just go into someone's field usually. And that's very helpful to kind of keep people out of the way.
Well, unfortunately for us, doing something like that would have the opposite effect. It would draw people to it. And actually, when we went to Black Rock to launch the Spacefarer rocket, it was the white fuming nitric acid furfural rocket. We went up there and we had filed a NOTAM. And normally when you're in the middle of the playa for the Black Rock Desert, you can look around and you can't see anybody. Well, that day that we were there, I had never seen so many people there other than for Burning Man than when we were going to launch this rocket. There are motorcycles, airplanes, RVs, cars, trucks. All these people just came out of nowhere to watch what we were going to do. And that's actually the opposite of what you want. You want them to go, oh shit, these guys are going to kill us. We need to stay away. So, another question? Did I see a hand?
So usually for procedures, do you have 3 different booklets for nominal, contingency, and emergency?
I would
You have
put
it all in one?
I would put, when you modularize them, you should put them together. Because it's easy to do a tab where you just flip from nominal to contingency and you start working your way back. And you could have them lined up one for one so that if I stop at this point, I then go backwards and fix things. And if you do if you're doing computer controls, that's also a good way to do it too. Is the countdown goes forward, and when you hit abort, the computer program should start running backwards and taking out everything in that order.
Is it worth putting into a system to which you can notify any aircraft in the airspace in real time of an impending launch?
That's what you can do
Yeah.
now.
There's- And you're not allowed to have an airplane radio to talk to people. Now, what the nice thing about us being in controlled airspace, military airspace, is we have Joshua Control, which we talk to, and they're the ones who talk to the airplanes and tell them, and they're talking to mostly the fighter planes and stuff coming in and out of the area, where the other planes like the Piper Cubs and all that kind of stuff, they're going through underneath the level that Joshua Control is taking care of. So they really say that we have to have 5 mile clearance view and where we can see stuff. But the bad thing is the guy who's usually doing the countdown is in the blockhouse. He has blinders on. He's got port that he's looking through at the rocket. He can't see other stuff. And that's why I'm saying the communication needs to be 2-way so that he can do his countdown and somebody else can say, abort.
In the heat of the moment, like, you don't want to be distracted anyway if you're doing a countdown unless something happens.
Right. And we have all kinds of distractions that come, like people driving onto the property right in the middle of countdowns, airplanes flying overhead. Somebody's in the bushes looking for their rocket and all of a sudden they show up and then you got to wait for them to get into a bunker. And the nice thing about FAR is that we actually have bunkers to get into. We don't have to follow the AAA&R rules for the distance. If we had to do AAA&R rules, the rocket would be a hell of a lot further away and we wouldn't be doing a lot of the stuff that we're doing, because you would now be having like a 1,000-foot line to control the rocket with that. And
permissible, going back to checking the airspace, it is possible to call Joshua and just check. They can look and see, you know, what's the nearest traffic to our location. I had to do that a couple of times in a particular weekend. Navy was planning something that they kept delaying, but it was nice to know the airspace was clear for particularly high launch.
So when you look at 2508, there's different regions on there for different bases. So we have China Lake to the north, we have Edwards to the east, and then there's traffic areas that they pass through to go to Nellis, which is at Las Vegas. Well, we just so happen to be in this multi-cross traffic area where they love to send cruise missiles through. So a submarine down by San Diego will launch a cruise missile, and they'll have a chase plane that'll follow it, and it goes right across Cone Dry Lake, right up the passageway, and they're going towards a target that's up at China Lake. And so that's the biggest one that they've held us for, that we had to stop our launches because of that. We stood down for 2 hours, then we came back up and continued on. But we got to sit there, oh, there goes the cruise missile. So, any other questions? So, we've been doing this since 1995, and we haven't had anybody killed yet.
So, everybody take a number, we'll do a drawing.
Oh my God.
And I've been mentoring the Cal State Long Beach guys for like 13 years now, and we haven't had anybody injured or killed. So I would hope that we could continue with that safety record.
For Canadian teams who want to do like test launches, who would be our best bet to contact in base 11 to help us with setting up those things?
Well, where are you going to do the test?
I know that some of us have thought about like Alberta is the closest one where we'd be allowed to. But it's just who can we contact to potentially give us a hand?
Well, maybe.
Work with Adam on that.
Yeah, Adam's probably a good guy to check for up in Canada.
Yeah.
Does
But-
Canada have triple, or is that just US?
I thought
We
that.
have a different organization, that's the Canadian Rocketry Association.
Right. You may want to contact them.
Yeah. Transport Canada has been very helpful in the past.
Yeah, the guys that really have the trouble with it is not Canada, but it's actually England. We've had people come over from England and launch over here because they just have so many restrictions on launching stuff. Matter of fact, I'm even surprised that Top Gear was able to launch their thing that looked like that spaceship. Yeah, the Robin. But they did it on a military base with military approval. So we're kind of unique here. And what's really nice is that California has rules with the California State Fire Marshal's Office that actually covers the launching of rockets. And I'm not sure that any other state in the United States has that. We actually have 3 classes of license. We have a class 3 that lets you do high-powered rockets, a class 2 that lets you build your own, and then a class 1 lets you do liquid rockets and you build your own hybrids. So that's what's kind of unique about it. And that's what's made it. So whenever, like if I want to do I need an explosives permit, the sheriff was going to say, well, you need to go get fingerprinted and stuff. Well, we already did that for the fire pyro-op license, so I don't have to do that again. So that's really a helpful thing, to actually have laws in place in your state. And it also keeps people from keeping you from doing it, because they could come and say, oh, this is unsafe, or whatever, we don't want you to do it. But the thing is that we have licenses, the state has already approved this, so we can do it without being stopped, unless if we're unsafe.
For final launches, when teams who aren't from where's baseball?
New Mexico.
Who aren't from New Mexico, what do we need to get to be allowed to do it in New Mexico?
I believe that you need to have your a certificate of authorization from the FAA, and I'm believing that any other permits and things that Spaceport America will have to work with us with Base 11 and not have to work with you guys to get the permissions. So things like NOTAMs and airspace clearances and all that stuff, I believe will have to be.
Like, say you have qualifications that you would need to operate something. Is there anything, say you're from a different state or a different country, they take care of it all for you?
Well, the qualifications for launching will be on Base 11 deciding, it won't be any local ordinances or anything. And also Spaceport America, I believe, will have to agree to whatever you propose. Any other questions? Okay, I think we're done. Okay, we're done on this end. I'm gonna stop sharing.